Hi guys, it's Mayor with another tutorial video. In this tutorial I'm going to teach you guys how to find equivalent resistance in an electrical circuit. But before we can get into that stage, we need to know what is a resistor. So, what is a resistor? Do you guys have any idea? Well, a resistor is something that limits the current I through the circuit. So what does this mean? It means that as our resistance increases, our current will decrease. Well, let's see if this makes sense. Based on Ohm's law, which V is equal to IR, where R is the resistance and V is our voltage, and as we know, I is the current. As we can see, as R increases, I will decrease based on V over R is equal to I, right? So as this increases, your amount of current will decrease, and as resistance decreases, your current will increase. Now that we have a basic understanding of the definition of the resistor, now let's see if we can, how can we find the resistance of one resistor? Well, this is another easy step. As we know, if you guys look at an actual resistor, it looks like something like this, right? It looks something like a peanut. So where you have 4 lines. So you have line 1, line 2, line 3, and then your line 4. Where line 1 is your first digit, right? Your line 2 is your second digit. Your line 3 is your multiplier. And your line 4, I'm going to draw a line here, is your percent error. So let's see if this actually makes sense. Imagine I have a resistor. It looks like this. There we go. Much better. Where I'm going to say the first color is going to be red. Right? The second color is going to be black. Let's see if black. I don't know if you guys can see it. Yeah, it's black. The third color is going to be orange. So this is my multiplier. And then the very last one is going to be gold. So how do we find the equivalent resistance of this? Well, there is a table for it. And you guys can see the table right now. Okay, based on the table that you guys just saw, and I have the link in the description, you guys can see that the red has a number 2, the black has number 0, the orange has a number that is assigned to 1000, so we have to multiply this by 1000, and then the gold is basically 5%. We will say this is a gold. Right? So now let's just make sense to see how much resistance this is. So we just write it. We just write 2, 0 times 1000 plus 5%, which is equal to 20 kilo ohms, on which it has a 5% error. So it can be 5% higher or 5% lower. Now that we know how to find the actual resistance for one resistor, let's see if we can find the resistance of resistors that are placed in series and in parallel. So let's start with series circuits. So series circuits. In series circuits, resistors are placed in the same branch, which means that they're basically in the same branch. I'm going to show you guys right now. But before we can get there, the resistors in an actual when I'm drawing it right here on the sketch and on the sketch diagram, they actually look like a bunch of squiggly lines like this. And this is one resistor, and I'm going to just write the number above it. Okay. So now let's say if I have a voltage source, right, that has the first resistor right here, right, and then I have another resistor down here. And let's just say this one is 10K, 10 kilo ohms, and then this one is 1 kilo. So how do we find the actual equivalent resistance of this? Well, this is pretty easy because it's in series. We can basically add up each resistor, which means that R eq of series, R eq series, is equal to R1 plus R2. Therefore, our Req is equal to 10K, 10 kilo ohms, plus 1 kilo ohm, which gives us 11 kilo ohms. Pretty easy, right? Now let's see if we can find the equivalent resistance of a parallel circuit. Parallel ones are a little bit tricky. So parallel circuits. So in parallel circuits, and the resistors are going to be placed in parallel lines. So which means that they're going to be in different branches, like this one. Imagine we have a voltage source down here, right? And then I have my first resistor down right here. Right? And then my second resistor will be down here. The first resistor is going to be, let's just say I'm going to assign a number for 10 kilo ohm. And then the second resistor is going to be a 1 kilo ohm, just like before. But this time they're basically both placed in parallel. So how do we find the equivalent resistance of this? And this is my voltage source. So our Req in parallel is equal to 1 over your first resistor plus the inverse of your second resistor. So you're basically taking the inverse of each resistor and then you're inversing that entire number. So let's see what is the equivalent resistance of this one. So let's start adding it. So 1 over 10,000, right? Plus 1 over 1,000. When we add them up, we get, which is equal to 1 over 11,000, right, over 10,000 multiplied by 1,000. Since the 1,000 can cancel out, so 1,000 and the 11,000 cancel out, which leaves us with 1 over 11 over 10,000. And when we take the inverse of this number, we end up with 10,000 over 11, which is 909.0909, and so on. This is in ohms. And that's pretty simple. Now let's see if you can actually do a more complicated circuit. So in this circuit, we're going to have a parallel and a series resistors combined. So like usual, we're going to draw our voltage source, and then I'm going to have one resistor right here, just like the series example, and then I'm going to have another resistor down here. Pretty much like a series circuit, right? Now I'm going to add another resistor across this one. And I'm just going to assign the numbers. So this one is, let's just say it's going to be 5 kilo ohms, this one is going to be 10 kilo ohms, and this one is going to be 10 kilo ohms. So how do we find the equivalent resistance of this? It's pretty simple. We have to break down the entire circuit. So we have to break the parallel part and divide it, and then break the series part. So to make matters a lot simpler, we're going to deal with the parallel part first. So in order to find the equivalent resistance of this, we have to be, as like before, it was 1 over 10,000 plus 1 over 10,000, right? Which is equal to 1 over 2 over 10,000, right? And then when we take the inverse of this, it becomes 10,000 over 2, which is equal to 5,000 ohms. Or, which is therefore my Req parallel is 5 kilo ohms. Now my circuit becomes a lot more simpler now, since I only have a voltage source down here, a 5k kilo ohms down, a 5k resistor down here, and another 5k resistor down here. So 5k, 5 kilo ohm. So all I have to do right now is to add up these two numbers and get my equivalent resistance. So let's just do it. So my Req for series is equal to 5,000 ohms plus 5,000 ohms. And then so my Req for my series is equal to 10 kilo ohms. 10 kilo ohms. And this number happens to be my overall equivalent resistance. So therefore my Req of the entire circuit is equal to 10 kilo ohms. I hope you guys enjoyed this video and actually learned how to find the equivalent resistance in different circuits.